how to work out how many moles of acid or alkali there are in a solution. So here we're given two solutions, one of acid and one of alkali. And the question would say there were 20 centimetres cubed of 0.1 mole per decimetre cubed HCl, hydrochloric acid. And in the right hand beaker there are 25 centimetres cubed of 0.5 moles per decimetre cubed NaOH, sodium hydroxide. I'm going to work out how many moles of hydrochloric acid there are in this beaker and how many moles of sodium hydroxide there are in this beaker. So the formula that you need is the number of moles in a solution, which is usually called N, is equal to the concentration of the solution, C, times the volume of the solution, V. Now the point to note is it says the volume of the solution in decimetres cubed, and usually the question will give you the volumes in centimetres cubed. So to go from centimetres cubed into decimetres cubed, you need to divide the volume by 1,000. So the volume in decimetres cubed of hydrochloric acid, what we have, is 20 divided by 1,000. And the volume in decimetres cubed of sodium hydroxide we have is 25 divided by 1,000. So plugging the numbers into the equation, if you have 20 centimetres cubed of hydrochloric acid, that's 20 divided by 1,000 decimetres cubed. The concentration is 0.1 moles per decimetre cubed, so it's 0.1. And putting 0.1 times 20 divided by 1,000 into a calculator gives you an answer of 0.002 moles. Same for the sodium hydroxide. The concentration of the solution is 0.5 moles per decimetre cubed, which we've kept in yellow. The volume of the solution in decimetres cubed is 25 divided by 1,000. So if you put 0.5 times 25 divided by 1,000 into a calculator, the answer you get is 0.0125 moles. Which means that in 25 centimetres cubed of 0.5 moles per decimetre cubed sodium hydroxide, there are 0.0125 moles of sodium hydroxide.